Okay, in this video, we're going to talk about lead screws and also ball screws, but they kind of fall in the same category. One typically is better for if you have like higher higher repeatability, you want it to be very robust over time, more like long-term durability usage. You might go with a ball version. For applications that don't need to last as long, you might go with a lead screw. But there's obviously other factors too that you may consider. But they all work pretty much the same way. So the concept of it is you have a threaded screw and then you have a nut that's gonna slide back and forth when the screw rotates. And then something is gonna attach to the nut, and then the thing that's being attached will be the object that's moving across the lead screw. So that is a general concept. That's why you see here there's lead screw, ball screw, and you have nut and ball nut. Um, so depending on what you choose, you will use the different types. But for this one, we'll just mostly focus on lead screws since the concept can carry over pretty smoothly. So one of the main things to look at is the thread. You have different thread sizes, just like normal screws. One thing to note is that depending on the thread angle, certain angles, especially if you go like steeper than 45, that's when you could start back driving it. But if the threads are, it might be different than 45, but the idea is if it's steep, the general idea is if it's steep, you could back drive it. And then if it's not steep, so pretty much the threads are close to horizontal, then those you probably can't back drive. So iGUS has some pretty good ones that you could look at as well. Here we're just looking at McMaster. I know some of these they actually also come from um, iGUS, some of them, but you could just take a look at their website for more details. So I think some of these, yeah, these actually might be the iGUS ones. I'm not sure which vendor this one's from, but typically they have the nuts they have could be plastic or a certain material, and some are like self lubricating. And then they also have like right hand, left hand, and they also have multi-start threads. So the multi-start one, you kind of see it here. If I click on one of these, maybe not this one. Let's see. Yeah, this one says ultra multi-thread channels. So if I click on this, yeah, you can kind of see here that there's like 4 points, 1, 2, 3, 4. That's how many starts it has. You can kind of see it there. And then based on what you want, you could choose the nut that's fit accordingly. So it also says here number of thread starts. So that makes it a little bit better. You can see here multi-thread channels create faster linear travel than lead screws with a single thread start operating with less backlash play. So that kind of helps with how if you try rotating the nut while it's on the lead screw, you could feel that there's not much give when you're rotating. So that's you would choose based on depending on your application. Some go up to 8 thread starts, and then this will have a different speed ratio. You'll have a different travel distance per turn. Um, so it just kind of comes down to what kind of application you're designing for. Okay, so here let's take a look at. We'll go with the M5. This one's the M5, and then let's see. So this one we have a thread pitch. The nuts here is M8. So let's choose one that has the same size. So we have a M5 2.5. So let's go with this one. And then this one is also M5. Okay, so we'll go with this pairing here since that's already good for us. And let's download this. We will put this in our lead screw. Okay, so that's our lead screw, and then this here is our nut. But if I put it in assembly, it could look something like this. So we have our nut and then our lead screw. So we could see here if I'm going to click the edge of the circle and then mate it to the outside. Sometimes a circle is not quite a circle, so it could make the mating a little bit hard. So sometimes one way around that is to add an axis. Sometimes if it lets you. Let me try mating it one more time in case there was some issue. Let me see if I mate this. It may or may not work. Yeah, I don't think it likes it. So sometimes when that happens, you could try another edge on there, or you could try creating a circle onto the surface of that. So if I open up the part and go normal to it, I could try sketching something on here so I know for a fact that it's a circle. So this is like a temporary hack if you want to mate it. Let's see if this works. So if I click this mate and then click that surface, see now you see that it mates, right? So if I go in here, you could see that um, as basically as this these screw turns, the nut will move. It'll turn like this, rotate. So if I hold one of these corners, it'll rotate like this, keep rotating, and then the nut will move along with it. Okay, so this is how something like this would look like. And let's say we have, so last time when we talked about the linear bearing, we were using the one that was already part of a block, but here maybe we have, let's just go with, maybe we have a flange one, for example. So we could use something like this. So the diameter of this, if I click this, it's a little bit hard to see, but it's a M8, right? So it's about 8 millimeters. So if I sketch a circle here, you can see that this distance, yeah, it's about 8 millimeters, which is like 0.325. So we could choose a corresponding shaft for the support to be about the same. But in this case, I think I'm just gonna go with the 1/4 inch. That should be fine for us. So I'm gonna go ahead and download this and save that. So in my assembly, right, because I have something that's driving this, um, you might have another part that's gonna be guiding it. Okay, so you could have two blocks like this, right? And this lead screw on one end might have to be driven by something. So sometimes what you'll see is if I open up this lead screw, you'll see sometimes the lead screw will have a step on here. Okay, so if I sketch here, this, maybe it will be a 0.25 inch. So I could have something like this. We'll check if it passes the thread, if it's too big, but let's just take a look. So we have this profile that's cutting, and let's make this, let's say 0.5 inches. Okay, so you can see that um, some of the threads show up. So from here, you know that 0.25 might be a little bit too small for the shaft diameter, or too big rather. So in this case, you could go with something smaller. So let's say an 1/8 inch. And if you're not sure too, you could also look at the standard size for the shafts, right? So we look it up, we could see that, I mean, there's a lot of sizes, but let's just click this. And you can see between the standard sizes that's available, so between 1/4 and 1/8, you have all these in between. So maybe 3/16 might be better. So we could take a look at what that would be if we were to choose 3/16. So 3 divided by 16". We could check. That should be fine. Okay, so you can see that 3/16 will be smaller than the thread. So that way this is a smooth surface. Okay, so if I go back here and if I hit OK, you see that now there's a surface for this shaft to mount on. Okay, so here we have a block, and one surface is going to be 0.709, and then this other surface is 0.5. So we could create a block here that will go in between. So if I sketch on the top plane and just create a block, maybe I make this 2 inches and this one 1 inch, and extrude boss this, make it 0.5 inch, for example. And we could check the tolerance on these blocks. So this one, this just says 0.709, so there's no real tolerance on here, so you can't really work with it. And then the other part we were looking at, this one here, if we click on it, you see that the outside is 1/2 inch, so also there's no tight tolerancing on here. Okay, so we could click here, 1/2 inch, 0.709. So typically, you know it might be a slip fit. So when I click this, the millimeters is actually 18.009. So um, I would just make it a slip fit, and then you can modify your part if it doesn't fit too well. Or you could have like a little slot as well to see if it could slightly flex when you insert it. So 0.709 and 0.5. So I'm just gonna use 0.709. So maybe 0.1 thou bigger. And then here maybe 0.501. And here perhaps I just want to kind of want to center it. So it's kind of arbitrary, but I'm gonna make this midpoint and then also make this midpoint. And I'm gonna extrude cut all. And you can make slots in between like we did with the other ones to make it clamp style. But you can see this one here has a face mount, so that will be a little bit different. Just gonna call this bearing blocks. I mean, it's not just for bearing, it's also for the nut. But you can see I could mate this to that, and then the surface could go onto that surface, and then this one, I think I got the wrong one. Let me delete this. The big one should go to the other one actually, so I'm gonna mate it to this one here. And then I'm gonna delete this. And the small one will go to the other face. And the face will mount to that. So this is a little bit bigger, so I'm gonna make it bigger as 1.25. So let's go ahead and make this 1.25. Maybe a little bit longer. Okay, so it will look something like this. And then you could mount one of this to the face of that. And you could add in a clamp on one side. So this one would be a face mount, so you can make this part threaded. And then the other end, you could attach a motor, and then this thing would slide back and forth. So right now my lead screw is floating. I'm gonna reverse that and fix the lead screw. So this would slide back and forth as like so, okay? So as you have a linear shaft here, so I could find a linear shaft, and then you could make, this will be, where's 1/4? Okay, I'm gonna download a 1/4 3-inch one, my least screw folder. So if I download this, I could drag and drop. Might need something longer because I have this to be 9 inches. So this is actually kind of too short. Can delete this. Let's get a new one. Let's get a 9-inch one here. Let's see. Okay, 9-inch download. Okay, so this one should be a better fit. And I could mate this in here and make it concentric. Okay, so it looks something like this, right? And maybe the ends of this might be attached to something. So you could have the ends attached to some block, for example. One side of this might be a thrust bearing, so you could add that in there as well. So I'm gonna actually, for this side, gonna open up, and you can actually mirror both of this because on the other side you might need something like a thrust bearing. So thrust bearings are good for linear shafts, and we went with a 3. We did a 3/16 earlier, so this is a thrust ball bearing. Because when a screw is turning, it's going to create a linear force, so that's why you need a thrust ball bearing. But it's going to look something like this. So if I put it on this end, you can mount it to this, and then the surface will mount to that face. Okay, so you have one face that's on, gonna be touching that. And then the other face would be, this is just gonna be, the other side would have the motor, right? So here, I could mirror this. So if I have a plane, let's see, there's a front plane. So I could go ahead and mirror this. So now I have one side where I could attach my motor, and then um, the other side will just be a thrust bearing. Okay, so if I go back to my assembly, yeah, it'll look something like this. And then this one here, I did a 3/16, right? So let's just say we're using a stepper motor, and they don't have a nice 3/16, but it's okay. We'll just choose this and download. Where did our assembly go? Okay, so this is our assembly. So you have a giant motor here. I can mate this to this shaft, and then this is where you could add a shaft coupling. Okay, so it's starting to come along together. Obviously, there's going to be some other parts you have to fill in, but you can see that you have two shafts, and then you could add the shaft coupling, like we discussed in the other one, and then you might have some structure on the sides to actually hold the ends. So here the shaft doesn't have to move, so this side could be locked, and then you could put a shaft collar here. So this one was a 3/16 to a 1/4 inch, so I could look up a shaft collar or shaft coupling. And then you can see 1/4 That's a 1/4 to 5/8. So they don't have the size that we want. So in that case, you might have to make a custom one, or you have to, yeah, you might have to make a custom one. So let's see. Yeah, 1/4 only goes higher. So that's where some of the design constraints come in. So because this one only goes up, this one's a little bit too small. So in this case, you can make a custom one. We can make a new part, and we could say like a top plane, just sketch. And let's say we were making this 1/2 inch. And let's make this 1 inch. So you could sketch on this face, and one face is going to be 3/16. And then we can make this blind and make this 0.5. And then the other side, we could make it 1/4 inch. So if I extrude cut this 0.5, so it looks something like that. So we call this shaft coupling. And then of course you would add your set screw holes or clamp, but for now I'm just gonna show how that would look like. So I could mate this to that. So yeah, it would look something like this. And usually the body of this might be a little bit bigger. You could go into detailed analysis if you want to be very precise. But we're not going to do that here. So yeah, you could add your set screw holes and all that good stuff. And then on this side, we could add, you could add in your mounting plates to make this complete. But that's pretty much the idea is you can also adjust the linear shaft so that there's more room for mounting. But you can see the pictures coming along together. You'll have a motor that rotates this lead screw with some shaft coupling, and then if both sides are mounted to some block, then it should be good and secure. So for the sake of completion, maybe we could add in another block here. So we could add this, and then we could say file, save as new. Save as a copy and open. I'm going to call this, let's call this M blocks. Keep the original document open. So in my N block, I'm going to edit my holes. So one of them was 0.25, and the other one was 3/16. Okay, so if I go back here, if I insert component, I could insert my M block. And this one here, because one side has the bearing, so I could actually make this 0.5. So the hole with the 3/16, let's just actually make that 1.5 so we could have the thrust bearing go inside. But typically the thrust bearing, one thing to notice is that um, you may just have part of it resting inside. So the thickness of this is only 0.193. So in that case, you might want to create a step. So in that case, I'm just going to actually leave this, and then gonna sketch one side to be 0.5, and then maybe one side will be like 0.1. I think it's 0.193, right? So if I go back to my assembly, we could see that this side here, we could mate it to this shaft, and then the surface will mate to that surface like this, and then this one will mate to this one. Okay, so this is how it would look like, and then obviously um, one of the blocks will be fixed, and then as the motor rotates, this thing will slide back and forth. Okay, and then you can also constrain this other end the same way that this has. The only thing that this one would need to add is something to captivate this shaft from slipping out. So you could add a shaft collar or some retaining ring back here, and then this other side you could have a set screw hole that comes down. Okay, so hopefully this gave you a good idea on how to put together a lead screw, a motor, and your linear bearings. So if you found this video helpful, give a like and subscribe, and I'll see you in the next one.